Hello everyone. As we saw tuple yesterday, so today we will continue with sets. So to start with some theory part, what is set? If you want to know what is set, set is a collection of unique. We need to understand why it is said unique because set does not contain duplicate values. It is a unique and unordered, means the order of the set is not fixed and it can add additional elements, that is it is mutable and it is enclosed in curly braces. So one can ask, why do we need sets? So we do need sets when you care about uniqueness, speed, and mathematical operation for collections. So while list and tuples are great in terms of storing the data, they become inefficient when you need to eliminate duplicates or perform frequent lookups. So mathematical handling of the data becomes easier when the data is in sets, right? So for storing, lists and tuples are great. However, for mathematical operations, it is always better to go with sets. So we have seen the definition. List is ordered mutable collection. Tuple is ordered immutable collection, whereas set is unordered mutable collection. Syntax is list enclosed in square brackets, tuples in parentheses, whereas set in curly braces. So this again other things which are there like ordering, mutability, allow duplicates or not. This we have already discussed. Whether list supports indexing, yes. Tuple, yes. However, sets do not support indexing. Reason is order is not fixed. Slicing is supported for list, tuple. However, for sets it is not supported. Reason order is not fixed. Hashable, lists are not hashable. Tuples are hashable since all the elements are immutable. Sets are also not hashable. Can be used in dictionary as key? No. Lists cannot be used as well as tuples cannot be, sets cannot be used, whereas only tuples can be used. So these are some comparisons which you can definitely work out from Google search as well when it comes to uh, understanding the various differences between list, tuple, and sets. But major differences I have already highlighted. Now let's understand the characteristics of sets. Set is an unordered collection. It is mutable in nature. It does not allow duplicate values. It can store heterogeneous data types. It has a dynamic size since you can add elements and remove elements. Elements must be hashable, that is immutable. You cannot perform indexing operations on sets and no slicing operations are also allowed. Reason, sets are unordered collections. So computing is very much easy for sets. Now let's deep dive into some coding. So first is defining a set. Now when I am defining a set, if I am saying a equal to curly braces, you might wonder whether a is actually a set or what, but if you can check type of a, it will provide you as a dictionary because default curly braces, if you are defining a for an empty uh, curly braces with a variable, then it will be defined as dictionary. So we can either define set as this 5, 6, 8, 9. Now you can see I have defined so many elements in the set. However, only those elements which are unique, they got added into the set. So this is how you can define the set. Or if you want to define an empty set, you can just say set of this. You can just define it. And this is how a set will be defined. And if you can check the type of A, it will say set. So we have just defined set, that is empty set. Along with that element also we have defined. We can check whether the set is heterogeneous or not. Now if you can see, set is a heterogeneous object. That is, it can contain different values. Using set constructor, we have already defined set. Suppose I am giving it as set of 5, 8. Now you can see you can only provide one argument over here. If you want to add set in a list, you can just provide the list in the set constructor. It will add it as a set. All the duplicate elements are removed over here. If you can see 8 was almost there for 4 times, it is now removed and it has become single element or unique element has been written. So using set constructor, you can convert list into set, tuple into set, string into set. Say if I am saying a equal to set, and I can say Python, and if I check python, it is there. Now it won't add elements as it is mentioned over here. It can add in a different way, phnoty, right? So that's why we are saying sets are unordered collection. So this is how we can check, define with range also, set of range 10. Now if you can check, A will have 0 to 9 elements. Now accessing the element in set. Now we have already defined few sets, that is A. Now if I want to access the element in the set, I can use for loop, iterator as well as next. So I can say for I in A, print I. So you can see I am able to print all the elements in the set. So what I'll do, I'll take a set which has a heterogeneous objects and I'll try to iter. So if you want to do iteration, iter is equal to iter numbers, and you can just mention number as a set which is there here. Okay, so it is now iterating numbers. You can also use next as an operator. For example, if I am saying iter number operator, so if I'm traversing, it will give me first number. If I check on the next, it will give me 10, 20 and 30. So I'll have to give next option to iter further. So we can just check whether this is possible for S also. Iterator is equal to iter, iter yes. So if you can see, each element is itered. Now coming back to adding the element, you can use add as well as update command. However, when you use add, it adds one element. Update doesn't add one element. When you add multiple elements, you have to use update. Except iterables means you can add list, tuple or dictionary in through update. Duplicate handling, ignored. Accepting multiple argument, it won't add won't accept multiple arguments, whereas update will accept multiple arguments. You can merge set using update, whereas you cannot merge set using add. So if you check adding elements, if I am having yes as my set and I say s dot add 25, and if I can check in s, see the 25 is added over here. If I say s dot add 25 comma 56, so it won't allow you to add. Reason is you have given two arguments. So that is how add works. Now if I can just quickly print set s, and if I say s dot update, and I can just give a list within 5, 6, 8, 9 and 10, and if I can print s, now you can see all these 5, 6, 8, 9, 10 have been added updated in the existing list, existing set. So that is how operations of adding element will happen. Now if we can check removing elements, there are five commands which can be used for removing element. Now s dot remove will give an error if element is not found. So if I am say s dot remove and I am removing 5, since 5 was there in the set, that's why I was able to remove. Now if you can see I don't have 5 now, so if I say s dot remove and I enter as 5, then this particular operation will result into key error. Reason is 5 is not found in that particular set. Now if I can check set here and I have another remove option, that is discard, s dot discard, say I am discarding 25, and if I am printing again as, now the 25 is discarded, and again I'll say s dot discard 25. The only difference is it won't give me an error and it will return me the set as it is. In remove, we were getting the key error. In discard, we won't get. Now, there is another way to remove is s dot pop. It will remove random element from the set and it will show you which element it has removed. So if you can see, I have true over here, which is now removed from the set. So I can just say s dot pop. Now you can see 4.5 it has removed. If I say s.pop and I give the element as 8, it won't take as an argument. Reason is for pop, when we are doing in set, we are not supposed to pass any argument. It does not take any argument. It will only remove random element. So we also have a clear function which will clear the set. Now if I can check set s and I say s dot clear, it will clear the set. So now S has become empty set. I will just again redefine S. S equal to, so this is a set which is defined now. And if I want to delete set S, I can just say delete S. It will clearly, you can clearly see the variable itself is now deleted. Now you don't find this particular variable as well as this particular set. So I'll just quickly redefine the set. Now you will be able to see that this particular set exists. Now we can just check which are the set operations that you can perform. Set operations you can perform. We have learnt in mathematics there were set operations that we used to do is set union, set intersection, then there is set difference and symmetric difference. This we can see. Now there are two sets I want to define, S and S1. Say if I am defining S1 as say 3 false, I'll say rows, then I'll add some duplicate elements as well. Now if I say S2 is equal to S1 union of S. S1 S union S union S1. So if you can see this is a union operator, so I can just add the set. Now if I say I'll just redefine these sets S and S1. So can I store in S2 S2 equal to S union S1? Yes, I will be able to. So this is how S2 has happened. Now if I say S union S1, it is giving me syntax error, maybe because I should use pipe the delimiter, then probably it is going to give me the union of it. Now we will just check on next operation, that is intersection. For intersection we have AND operator. So if I can say S2 intersection, that is AND operator, and S, it will give me the intersection of S2 and S. So in from S and S2, following elements are common elements. Now difference you can use minus, say S2 minus S1, it will give me remaining elements which are not there in which are there in S2 but not there in S1. So all those elements you will get. Symmetric difference you can use raise to command. So if I am just creating this set S1, I'll just create all the sets again so that we can have those sets created. Now if I say S2 symmetric difference S, now you can just see whatever elements that are there in S2 but not in S, those elements will be written. So S has 10, it is not written. 3, it is not written. 4.56, it is not written. Python, it is not written. True, it is not written. So false and ROS will be written. So this is how symmetric difference will work. Now updating the set operations. Now these are the few things which I would like to tell you. What are the updating set operations? So updating set operations, there are four operations that you can do: update, you can have intersection update, you can have difference update, you can have symmetric difference update. Now just to understand, I have few examples over here. Say A is 1 2 3 set, B is 3 4 5, and if I say A dot update B, then if I print A, entire elements of A and B will be updated together and all the duplicates will be removed. So what I'll do, I'll just quickly copy this and I'll paste it here. I'll remove all the spaces so that you won't get any error. Now you can just see how this update works. So 1, 2, 3. 3 is a common element, so it has come once, and 4, 5. So all the element of A and B are updated. Now we will check with the intersection update what will happen. In the intersection update, if you can see, there is set A, there is set B. In the intersection update, you can only check, it will keep only the common elements between both the sets. Means I am finding intersection of both the sets. So all the elements which are not common will be removed. I'll just quickly comment this line and quickly remove the spaces. So you can see only 3 and 4 will be there for set which is updated. Now I'll just tell you what is the difference update. Now when I am talking about difference update, it removes all the element from the set, first set, that are there in the another set. That means suppose I have set A as 1, 2, 3, 4. It will remove all the element from the set A which are there in other set. That is 3 and 4 is there in other set. So 3 and 4 will get removed and only 1 and 2 will be there in that particular set. So we'll just quickly check the difference update so that you will be able to understand how it works. So if we can execute it, I'll just comment this line. Now if you can see in the difference update, it will only remove all the elements present in set B which are not there in A. So if you see 1, 2, 3, 4, it will keep only 1, 2 which are not there in B and it will remove 3 and 4. It won't consider 5 as of now. Now then there is a symmetric difference update. So if you can see, this is a command or this is a way, what you can do is keeps only element that are unique in each set and remove all the common elements. Means what? Here we were not touching the set B, we were only concerned with set A. But in symmetric difference update, what it will do, it will check set A, what are the common elements of set A are present in set B. It will remove the common elements and it will only keep the unique elements of both the sets. So you can just quickly check how it happens and I'll just quickly print. So if you can see 3 and 4 from set A, 3 and 4 from set B are removed, whereas only 1, 2 and 5, 6 is kept as it is. Now we can just see for membership operators. So I'll just check set A. Now if I say 5 in A, if 5 is present in A, it will return me true. If I say 10 not in A, so since 10 is not in A, so it will still present me as true. So iterating through sets I have already shown you. We can use for loop, we can use iter, we can use while with iter as well as enumerate. Now we will check the built-in functions in set. So I have a set which is A and these are the built-in functions which are there for the set. So if I say length of A, it will give me 10. Then I can say max of A, it will give me the maximum element. If I say min of A, it will return me the minimum element. If I say sum of A, it will give me the summation, right? And if I say sorted A, it will give me a sorted list. Now you need to understand, I had a set. However, the returned element is in list. Reason is when we are talking about set is an unordered collection. So ordering is not possible. That is why the returned element is in list. Then I can say reversed. So it will give me the type error. Reason is reverse is not allowed in set. Then I can say type of A. We have already seen it will return me set. Then ID of A will give me the memory location of that set. So that is how built-in function work. Now in the set, we also have a frozen set. Since set is a mutable collection, frozen set becomes immutable version of a set. So that's the only difference. We can have a immutable version as well. Once it is created, you cannot add, remove or modify any elements. So how you define a frozen set? You can just say A is equal to frozen set and you can just add some elements, say 5, 6, 8, 9, 10, 71. Say I'll give this parenthesis, and if I can just check, A is a frozen set. So defining a frozen set can also be done by curly braces. If I am just checking this as frozen set and I am using curly braces, that is also fine. 8, 9, and this is how also you can define the frozen set. Now let's understand. Will we be able to remove any element? B dot pop, if I can check. See, frozen set does not have any attribute for pop. So that is not possible. So this is a immutable frozen set. Add and remove operations are not possible in that. Now there are again set comparison options are also there. So what it does is you might have heard about subset. That means element A and B are, if I am comparing, all the element of A are present in B. So A is subset of B. Superset, all the elements of A and B, if we are comparing, if we say A is superset of B, then it will return me false since all the element of A is not present in B. Whereas A is superset of B, whereas B is not superset of A. So that is how it is. It will return me true here. And if I say B is superset of A, then it will return me false. Proper subset, A is 1, 2, B is 1, 2, 3, print A less than B, then this is going to be a proper subset. Proper superset, A is 1, 2, 3, 4, B is 1, 2, A is greater than B, then that becomes a proper superset. And disjoint set means elements of A and elements of B should be absolutely disjoint. Then it should give me the disjoint whether it is true or false. Now let's work out these examples. First we will do set comparisons for subset. So I have just created two sets. Now if you can see, A is subset of B, true. A dot is subset B, true. So all the elements of A are present in in the set B. Now we will just check for the superset. We have defined two sets. Now A is superset of B. It is saying true. Now we will just write another command stating B dot is superset of A. Now if you can see, this is false because all the element of A are not present in B. So B cannot be superset of A. In the same way, we can just check the proper subset. So A has 1 and 2, B has 1, 2, 3. A is less than B. That means A's elements are present in B. So A is proper subset. Then we can just say proper superset. So if you can see here, A is 1, 2, 3, 4, B is 1 and 2, A is greater than B. All the element of B should be present in A, so that is true. Now if you can see disjoint sets, we can just check. In the first case, A is equal to 1, 2, 3 and B is equal to 4, 5, 6. All the element of A and B are different. So A is disjoint of B. That is true. In the second case, if you see 1, 2 and 3, whereas 3 is a common element between A and B set. So when I'm saying A is disjoint of B, then it becomes false. That is why it is false. So that is all about set operations. We have traversed through all the functionalities that set has, right from built-in functions, then methods that are there for sets, then set comparisons, then uh, set operations, also symmetric difference, and that is all about set. We will in the next lecture we can just check what we can do in the dictionary as well, so that it will be more of a coverage that has happened for all the data types in Pythons. And after that, we will gradually proceed towards loops, that is for loop and while loop. And after while loop and for loop, we can just go ahead with some additional functions, and that is how we can create our own functions and lambda functions, then map, filter, and reduce functions that we can do in the future lectures. Thank you.